This is lesson 10, calculating slope, and this is activity 3, making designs. In this activity, students work in pairs. One student gets a blank sheet of graph paper, and a second student gets a graph with these 6 lines graphed on it. And what the student's supposed to do is describe these lines in such a way that the partner can draw these 6 lines only from the information given to them by the student. They can't look at these graphs. They just have to be able to draw it on the graph paper based on the description. And then you can switch roles, and the second student can get the graph paper, and the other student can get this set of lines and describe these lines so that the person with the graph paper can draw these lines on that graph paper. Now, to draw the lines, you need 2 pieces of information in general. First of all, you need one of the points on the line, and you need a second point. So you need 2 points to draw a line. And however you describe those 2 points is fair. They can then draw the line based on those 2 points. Now, we've been working on developing the equation for a line and developing a formula to write that equation. And that includes 2 properties of lines. One property is the slope. That's the m in the equation. The other property is the y-intercept. That's the b in the equation. Now, you should practice, and I would suggest that students practice saying what the slope is. Now, you don't have to say what the y-intercept is. You could use any point on the line and the slope and draw that line. You will get the correct line. But you might practice just identifying the y-intercept and beginning there. And so that's what I did here. The y-intercept is written as no change in the x-axis, so it's 0 for the x-coordinate, and then it's how much of a change there is along the y-axis. So this point right here is labeled 0, 5. So it's 0 along the x-axis, and it's 5, a positive 5 units. This is 0, 3. This is 0, 1. Now this one is 0, so it's 0 moving along the x-axis, but this is 0, negative 1, 0, negative 3, and 0, negative 5. So you get used to writing coordinates on the y-axis that has 0 movement along the x-axis and then the value of the y-coordinate, whatever that might be. Now, don't get confused. They set this up so that these 3 positive y-intercepts also have positive slopes. And these 3 lines are parallel. That means they're going to have the same slope. And we'll look at that in just a moment. And these 3 lines down here, these 3 negative y-intercepts, all have negative slopes because they're going downhill from left to right. Now, don't get confused. Because it has a positive y-intercept, it could still have a negative slope. The line could be going from up here through this point down here. As a matter of fact, if I were to redraw this activity, I'd reverse these lines. I'd have these 3 lines go through these 3 points, and these 3 lines go through these 3 points. What's going to happen is that the lines are all going to go in this direction down to here, and then in essence reflect back in this direction, back this way. So you might try drawing that. You might see how that looks as far as the equation if you draw the opposite image. But let's start with what they gave you. So I would tell the student that the line is going to go through the point 0, 5, and that this slope is, how many units does it move along the x-axis? It moves 3 units along the x-axis and 1 unit along the y-axis. So for every 3 units, it moves up a positive 1 unit. 3 units, positive 1. 3 units, positive 1. You can also, so that's this slope right here. 3 units, positive 1. 3 units, positive 1. You really only need these 2 points. They could then draw the line based on those 2 points. Now you could say it moves 6 units and positive 2. You're going to get another point on the line. Or you could say it moves in a negative direction, a negative 3 units and a negative 1. So that's also a positive 1/3 for the slope. So negative 3, -1. So this is a -1 for the y, change in y, and a -3 for the change in x. That is a positive slope. -1 over -3 is a positive 1/3. And a positive 1 over a positive 3 is also a positive 1/3. Has to have the same slope. So there's practice working with negatives, practice on drawing the slope, using the slope in either direction, practice using the slope as a multiple of this. So both the y direction and the x change are a multiple. So it's 2 times 3 and it's 2 times 1. Whatever you want to do to describe that. Now, notice that B and C are translations of A. So you could just describe B as a vertical translation moving down 2 units. Every point on this line moves down 2 units. So just take your drawing of A and slide your drawing of A down 2 units. Or you could start over again, use any of the points along this line and say what the slope is. The slope is the same because they are parallel. So the slope, if I started here, the slope is 1 unit in the vertical direction over 3 units in the horizontal direction, so it's 1/3. If I start here and go this way, it's a -3 and a -1, so it's a -1 over -3. So that's a negative 1/3 if I go from this point to, I'm sorry, positive 1/3, but it's -1 over -3. So it's a positive 1/3 still. So if I start here and go to this point. So however you describe it, and C is a vertical translation of B, a -2 units, or a vertical translation of A, a -4 units. Again, however you want to describe those. And notice that if you move to these 3 lines, they are also parallel lines. So they're also going to have the same slope. But now that slope is actually the additive inverse of this slope up here. So instead of a positive 1/3, what's the additive inverse of a positive 1/3? It's a negative 1/3. So it's a negative slope. So it's in the vertical direction, -1 unit for every 3 units in the positive direction. So that's a slope of -1 over positive 3, or a positive 1 over -3. These have to have the same slope because it's the same line. So if you go in the x direction, -3 units, and up a positive 1 unit, that's a slope of positive 1 over -3, positive 1 over -3, which is a -1/3, or a -1 over positive 3, which is also a -1/3. And notice that they are additive inverses. There's not really any meaning behind that other than that they're additive inverses. So they go in the opposite direction the same amount. All right, so if you draw this line, so you give your partner the y-intercept. So this is at 0, -5, 0, -3, and 0, -1. And then the slope has a slope of a -1/3. So wherever they choose, so they could, well, actually they have to choose. If you give them the y-intercept, they have to start at that point. But you could give them a different point. This point here is -3, -1, 2, 3, 4. So you could give them this point right here. So that's a slope of -1/3. So they're going to go, for every positive 3 units, they're going to go down a -1 unit. So they would end up here. So whatever you want to do, you can practice describing a line different ways. And notice that E is a vertical translation of a positive 2 units. So it slides up 2 units. And D is a vertical translation that slides up another 2 units, or again 4 units from F. However you want to describe it. And again, you can begin at the y-intercept and say what the slope is. It's a -1/3. So they're going to, for every 3 units in the horizontal direction, that's a -1 unit in the vertical direction. So they're going to end up here. They could draw this line. So whatever, many ways to do this. For the second set of graphs, students can switch roles. And to describe these graphs, what I did is I worked with the lines. First of all, notice that all of these lines have negative slopes. They're all starting in the upper left quadrant and moving, as you move from left to right, moving to the lower right quadrant. So they all have negative slopes. And I started with the two lines that have the steepest slope. And that's line H and that's line K. So I started with those two. And so they start here and they extend up here. So if you look again up here, you can see where they are up there. And then I went to the two lines that have the shallowest slope, or the least steep slope. And those are P and N. So these two lines here, and they go through the quadrants and end up over here. So I'm going to go back and forth. Whoops. And then I finished with the two lines in the middle. And so those two lines are right here. So I finished with these two lines. The two lines here, and they extend through to the two lines down here. So I started with these two lines, then I went to these two lines, and I finished with these two lines. And again, they are up here. I started with these two lines up here, went to these two lines here, and finished with these two lines in the middle. Now, once again, to draw a line, you need 2 points. And however you identify those 2 points is fair. That's the point of this activity, is to figure out different ways to do that. And so to begin with this first line, H, I used the x-intercept, where this line crosses the x-axis. Different from the y-intercept, where it crosses the y-axis, which is up here, right here. But I used this point down here because I wanted to keep away from where all these lines cross each other. And so I started here, and I thought, okay, how far do I have to go over and then go down to get to this point? So I'm really identifying 2 points on the line and figuring out what the slope is based on those 2 points. So this is a positive 1 unit along the x-axis and a negative 6 units along the y-axis. So that slope is, for every positive 1 unit along the x-axis, it goes down 6 units. So it's a negative 6 in the y direction and a positive 1 in the x direction. So that gives you a slope of negative 6. And once again, you can go up if you want, and over, or to the left and up, or you could go down first and then to the right. However you think about it, it's fair to do that. And you could use a different point, although those go off the page. So you're really kind of stuck with just a few points to choose from. And you want to choose, again, a point that crosses, that is on the intersection of the grid, so you know exactly where that point is. All right, so you draw this line. This has a slope of negative 6, starts at 1, 0. So this point's labeled 1 along the x-axis, 0 along the y-axis, and it moves to this point down here, which is 2, negative 6. Now, the next line crosses the x-axis at positive 2. So this is positive 2, 0. So it's 2 units along the x-axis, 0 units along the y-axis. So this is 2, 0. And what's the slope to go from this point to this point? So I'm just going down this line and I'm finding, where does this line intersect with the grid? And it's down here. And so that's a positive 2, negative 5. So for every positive 2 units along the x-axis, it's a negative 5 units along the y-axis. So it's the change in y over the change in x. So it's negative 5 over positive 2. So that's a slope of a negative 5 halves. So now I'm going to go back up to here and do line P right here, because these two slopes are related. Talk about that in a moment. And this slope, so where are 2 points that are on the line that intersect with the grid? I could choose here And here, I actually could choose this point and this point way over here if I want. But let's choose this point, which is the y-intercept in this case. So this is 0, 1. So 0 units along the x-axis, 1 unit along the y-axis, and it goes to the left 6 units. That's -6 along the x-axis and a +1 along the y-axis. So for every 6 units in the negative direction, it goes up 1 unit. Or for every 6 units in the positive direction, it goes down 1 unit. You can talk about the slope either way. It's fine. So for 6 units along the -6 units along the x-axis, it's a +1 unit along the y-axis. So that's a slope of +1 over -6, which is a -1/6. So P has a slope of a -1/6, and it begins, you can draw it by beginning at this point here, which is 0, 1, and getting to this point here, which is -6, 2. So you should label the points as you do this. Now notice the relationship between these two slopes. If you multiply them together, you get an answer of a +1. These are multiplicative inverses or reciprocals of each other. So a -6 and 1 over -6 are a -1/6. So a negative value times a negative value always will equal a positive number. So 6 times 1/6 is 1, and it's a +1 because it's a negative times a negative. All right, the next line. This line is related to n, or related to k, sorry. So this is line n, which is also related to k. So I want to put these two together. And I'm going to start with the y-intercept for this line. So this is at 0, +2. That's the y-intercept, 0, 2. And where's another point on the line that crosses the grid, that intersects with the grid? And it's up here, right here. So I'm going to go to the left 5 units and up 2 units. So for every -5 units, the change in y is a +2 units, or for every +5 units, the change in x is a the change in y is a -2 units this way. So I could go this way and down, and I chose to go to the left and up 2 units. Regardless of how you do that, you're going to get a slope of a -2/5. So it's a -5 along the x-axis and a +2. So +2 over -5 is a -2/5. So notice when you multiply these two slopes together, what answer do you get? Once again, if you multiply two negatives together, you're going to get a positive answer. And these, the product of these two slopes gives you an answer of 1. They are multiplicative inverses. So it's going to be a -10 over a -10, which is a +1 if you multiply them together that way. All right, the last two lines are the two lines that are in the middle, M and L. So it's line L right here and line M right here. So these two lines that are in the middle. So line L, I'm going to go back to using the x-intercept. Again, I'm trying to stay away from all of these lines that cross in this area. So I'm going to go back to the x-intercept, and that is 3, 0. So this goes out 3 units along the x-axis and 0 units along the y-axis. I just have to find another point that intersects the grid, which is right here. And what's the slope to get to that point? It's a +3, -4. So for every 3 units in the positive direction along the horizontal axis or the x-axis, it's a -4 units along the y-axis. So that's -4 over +3, which is a -4/3. So this has a slope of -4/3, and you can get those 2 points by beginning with the x-intercept and using the slope of a -4/3. Now that also means you can go a -3 units, 1, 2, 3, and a positive 4 units, 1, 2, 3, 4 along the y-axis, you're going to land on the same line. It's the same slope. It's just a positive 4, negative 3. Doesn't matter how you do it. And this is practice actually. You should probably try both ways. And the last line is line M. And again, these two lines are related as multiplicative. Their slopes are multiplicative inverses of each other. So I'm going to start with the y-intercept. So it's 0 along the x-axis, and it's 1, 2, 3 units along the y-axis. So the y-intercept is 0, 3. To get to another point that intersects the grid, I'm going to go up to this point right here. So I'm just looking for where does it intersect the grid, both the horizontal lines and the vertical lines. It's right here. So to get to that point, I have to go to the left, 1, 2, 3, 4. So that's negative 4 units along the x-axis and a positive 1, 2, 3 units along the y-axis. So that slope is a positive 3 over negative 4. So positive 3 over negative 4. So that's a negative 3/4. Multiply these two together. Again, you're going to get an answer of positive 1. Now, I could have chosen to go up 3 units first, positive 3, 1, 2, 3, and a negative 4, 1, 2, 3, 4 along the x-axis. That would be a positive 4, negative 3. That would be, if I chose, this would be a positive, oh, I'm sorry. If I start here and go backwards, and this is the reason for doing this and trying different ways, because it's being as comfortable with the language as you can. If I start here, this is a positive 4, 1, 2, 3, 4, negative 3, 1, 2, 3. Sorry. If I start here and go to here, whether I go this way and up or this way and over, still going to be a negative 4 along the x-axis and a positive 3 along the y-axis, no matter where I start and what direction I go. If I start here and go this way, then it's going to be positive 4, 1, 2, 3, 4. If I go down and over, it's still going to be positive 4, 1, 2, 3, 4. But it's going to be a negative 3, 1, 2, 3, or over here, 1, 2, 3. So however you do it, just practice doing it a variety of different ways. You become more and more comfortable with identifying the slope, identifying where the line intersects both the y-axis and the x-axis, and how you get that second point so you can draw the lines.